In this video, we are going to study rational inequality. But before that, let us understand rational function. Rational function is in the form of ratio of two polynomials px and qx, where qx is not equal to 0. After dividing px by qx, if we get quotient equals fx and remainder equals rx, then we can write dividend px equals quotient fx into divisor qx plus remainder rx, known as division algorithm. Here, thing to be noted is if degree of px is greater than or equal to degree of qx, then remainder rx is either 0 or degree of rx is less than degree of qx, and then we write px equals fx plus rx upon qx. So these are some basics of a rational function, but in this video we are going to study specially rational function when it is positive or negative, and how to find solution set of these inequalities. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Rational inequalities px upon qx less than 0 or greater than 0 can be solved as follows. First, polynomials px and qx are equated to 0. Polynomial equations px equals 0 and qx equals 0 are solved to find the critical points, which are the values of x, say a, b, c, etc. These points are plotted on a number line a, b and c. Next, the signs of factors of polynomials px and qx are tested in the neighborhood of the critical points a, b and c, on the basis of which whether px upon qx is negative or positive is checked, and the corresponding intervals give us the solutions of these rational inequalities. Let us understand what we have discussed here by actually solving some examples. Solve x plus 1 upon x plus 3 less than 3, x plus 1 upon x plus 3 minus 3 less than 0, x plus 1 minus x minus 9 upon x plus 3 less than 0, minus 2x minus 8 upon x plus 3 less than 0, minus 2 into x plus 4 upon x plus 3 less than 0, x plus 4 upon x plus 3 greater than 0. X plus 4 equals 0 gives x equals minus 4. X plus 3 equals 0 gives x equals minus 3. We show these points on a number line minus 4, minus 3, negative infinity, positive infinity. We prepare a chart of interval x plus 4, x plus 3 and x plus 4 upon x plus 3. We have intervals minus infinity to minus 4 will be positive when both numerator and denominator are negative. For the interval minus 4 to minus 3, if numerator is negative and denominator positive, rational function will be negative. For the interval minus 3 to infinity, if both numerator and denominator are positive, rational function will also be positive. So from minus infinity to minus 4 and from minus 3 infinity, we are getting the value of rational function positive like we want here. So the solution set of this rational inequality is union of these two intervals minus infinity to minus 4 union minus 3 to infinity. There is one correction here. Instead of minus x, here it should be minus 3x. And to show the solution set on the number line, it will be from minus infinity to minus 4 excluding minus 4, and from minus 3 to infinity excluding minus 3. Solve 2x minus 3 upon x minus 2 into x minus 4 less than 0. Here, putting 2x minus 3 equals 0, we get x equals x minus 2 equals 0. We get x equals 2. X minus 4 equals 0. We get x equals 4. Let us show these points on a number line. 3 upon 2, 2 and 4. Let us prepare a chart for various intervals, then terms in numerator and denominator. 2x minus 3, x minus 2, x minus 4, product of x minus 2 into x minus 4, and finally the rational function 2x minus 3 upon x minus 2 into x minus 4. First interval from minus infinity to 3 upon 2. If 2x minus 3, x minus 2 and x minus 4 are all negative, then the product x minus 2 and x minus 4 will be positive, and this negative upon positive will give value of the rational function negative. Next interval 3 upon 2, 2. If 2x minus 3 the numerator is positive and both factors in the denominator are negative, then the denominator will be positive and both numerator and denominator are positive. The rational function will also be positive. Third interval 2 to 4. If numerator is positive, x minus 2 is positive but x minus 4 negative, then the denominator will be negative, and since numerator is positive, denominator is negative, the function will also be negative. And finally, interval 4 to infinity, if 2x minus 3 is positive and x minus 2 and x minus 4 both are positive, then since numerator is positive and denominator also positive, will give the function positive. So the interval satisfying this inequality is minus infinity to 3 upon 2 and from 2 to 4. So the solution set will be union of these two intervals minus infinity to 3 upon 2 union 2 to 4. The same can be shown on a number line from minus infinity to 3 upon 2 excluding 3 upon 2 and from 2 to 4 excluding the endpoints 2 and 4. Solve x cube into x minus 1 upon x minus 2 greater than 0. First we will write polynomial equations. X cube equals 0 giving x equals 0, x minus 1 equals 0 giving x equals 1, and x minus 2 equals 0 gives x equals 2. So these are the critical points. We will plot these critical points on a number line 0, 1, 2, negative infinity, positive infinity. Now we will prepare a table for intervals and factors. Interval x cube x minus 1, numerator x cube into x minus 1, denominator x minus 2, rational function x cube into x minus 1 upon x minus 2. The first interval is minus infinity to 0. If x cube is negative, x minus 1 is negative, then the numerator x cube into x minus 1 will be positive, and if denominator x minus 2 is negative, then the rational function will be positive upon negative, negative. Next interval from 0 to 1, x cube positive, x minus 1 negative. So x cube into x minus 1 will be negative and denominator is also negative. So the rational function negative upon negative will be positive. Third interval from 1 to 2, where x cube is positive, x minus 1 is positive, so the numerator will be positive and denominator negative. So positive upon negative will be negative. And finally the last interval 2 to infinity, where x cube is positive, x minus 1 is positive, numerator is positive and denominator also positive, and positive upon positive will be positive. We have to choose positive values of rational function. So in interval 0 to 1 function is positive, and in the interval 2 to infinity also it is positive. So the solution set will be union of 0, 1 and 2 to infinity, which we can show on the number line 0 to 1 excluding 0 and 1, and 2 to infinity excluding 2. Solve x square minus 4 upon x square minus 2x minus 15 less than or equal to 0. We rewrite this by factoring numerator and denominator. So it will be x minus 2 into x plus 2 upon x plus 3 into x minus 5 less than or equal to 0. Polynomial equations will be x minus 2 equals 0, giving x equals 2, x plus 2 equals 0, giving x equals minus 2, x plus 3 equals 0, giving x equals minus 3, x minus 5 equals 0, giving x equals 5. Now we will plot these critical points on a number line and search our solution. So minus infinity, minus 3, minus 2, 0, 2, 5 and infinity. Next we write the intervals. Factors in the numerator x minus 2, x plus 2, then factors in the denominator x plus 3, x minus 5, then the rational function. The first interval minus infinity to minus 3, factors in numerator and denominator all negative, giving a rational function positive. Second interval minus 3 to minus 2, factors in numerator negative, in denominator x plus 3 is positive, x minus 5 negative, the resulting rational function negative. Third interval minus 2 to 2, x minus 2 negative, x plus 2 positive in the numerator, x plus 3 positive, x minus 5 negative in the denominator, the resulting rational function positive. For fourth interval 2 to 5, both factors in numerator are positive, x plus 3 factor in the denominator is positive and x minus 5 negative. So the resulting value of the rational function will be negative. And for the last interval 5 to infinity, all factors in numerator and denominator are positive, giving the rational function a positive value. Now the two intervals minus 3 to minus 2 and 2 to 5 make the rational function negative. So the solution set of this rational inequality will be union of these two intervals minus 3 minus 2 union 2 5, which can be shown on a number line minus 3 to minus 2 excluding minus 3 and minus 2, and second interval from 2 to 5 excluding 2 and 5. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.